Hello everybody! In this lesson, we will deal with calculations with square roots and cube roots in algebraic expressions. Let's find the square root of a product. Now, what you do is, remember the word product in mathematics means multiplication. So here, when you see 2a times 2a, you will first simplify that expression under the square root. And how you simplify is, now you have to remember your rules of exponents. And the rule says when you multiply, you add exponents. So that will simplify to 4a squared. And now, to find the square root there, you will say, remember there's an invisible 2. So on the 4, you will say the square root of 4 is 2. And on the a, you will divide the exponent by 2 and you end with 2a. On the next sum, what you will do is first you will simplify whatever you find under the square root. And then it will be 6 times 6 is 36. And y times y is y squared. When the bases are the same, we add exponents when we multiply. Now, there's your invisible 2 again. So you will say the square root of 36 is 6. And in terms of the y, you will divide the exponent by 2. The third sum, first you simplify by saying 5t squared times 5t squared is 25t to the 4. Where does the t to the 4 come from? When you multiply, you add exponents. And there's your invisible 2, so you'll say the square root of 25 is 5. And on the t, you will divide the exponent by 2. Therefore, the answer 5t squared. When I give you this one, 4b to the 3 times 4b to the 3 will become 16b to the 6. And now we find the square root there. So the square root of 16 is 4. And then on b, we divide the exponent by 2. Therefore, it's 4b to the 3. On this one, you must be careful because this variable there is x to the 4 and the variable there is y to the 10. So they are not the same. You cannot apply the exponential rule there. So all you can do is you can say 3 times 3 is 9, and then instead of writing this multiplication sign, you simply write them next to each other. And now you can take the square root. So there's the invisible 2. So you say the square root of 9 is 3. And on x to the 4, you divide the exponent by 2. Therefore, it's x squared. And on y to the 10, you divide the exponent by 2. And you end with y to the 5. Now we will find the cube root of a product. We will go about finding the cube root of a product exactly the same as we did with the square root. So first of all, we will take whatever is under the cube root and we will simplify that. Therefore, we end with 8b to the 3. Where does the 8 come from? I say 2 times 2 times 2, and b to the 3 was the rules of exponents. When you multiply and bases are the same, you add exponents. Now, to find the cube root there, you will say the cube root of 8 is 2, and in terms of b to the 3, you will take that invisible 3 and you will divide the exponent. Therefore, the answer 2b. The next sum, first you will simplify under the cube root. So 10a times 10a times 10a is 1000a to the 3. Now, the cube root of 1000 is 10, and on a to the 3, we will divide the exponent by 3. Therefore, the answer is 10a. The third sum there, we simplify under the cube root, and we say 3 times 3 times 3 is 27, and x squared times x squared times x squared. Remember, When bases are the same and we multiply, we add exponents. So it becomes x to the 6. Now the cube root of 27 is 3, and the cube root of x to the 6, we will divide the exponent by 3, and we end with 3x squared. On this one, again we multiply and we simplify under the cube root. Therefore, 3 times 9 is 27, and y squared times y to the 10. When bases are the same, we add exponents. Therefore, it's y to the power of 12. Now we can say the cube root of 27 is 3, and then the cube root of y to the 12, we divide the little 3 into the exponent, and the answer 3y to the 4. On this one, again we simplify under the root, the cube root. We say 5 times 25 is 125, and then t to the 9 times t to the 9. When bases are the same and we multiply, we add exponents. Therefore, it becomes t to the 18. Now we can find the cube root. The cube root of 125 is 5, and then the cube root of this t to the 18. We will take this little 3, we divide the exponent by 3, and the answer 5t to the 6. Finding roots of a quotient. What does quotient mean? It means it's a division sum. So on the first one, a to the 7 divide by a. When you think of your rules of exponents, when you divide, you subtract exponents. Therefore, if on the a, there's an invisible 1. And now you can say it's a to the 7 minus 1 is a to the 6. So that thing you will first simplify, and it simplifies to a to the 6. Now you can take the square root of a to the 6. Remember, there's an invisible 2 on the exponent. We'll divide the 6 by 2, and the answer a to the 3. On the second sum, the cube root of that, what you do is you deal with each element under the cube root individually. So you will simply say the cube root of 125 is 5. The cube root of k to the 9, you will take the 3 and you will divide the 9 by 3 on the exponent. So it becomes k to the 3. And then under the line, the denominator, you simply say the cube root of 8 is just 2. On the third sum, again, there's 3 elements and we deal with each one individually. So therefore you will say the cube root of 27 is 3. The cube root of x to the 3, we'll divide the exponent by 3. So it becomes x. If there's nothing, there's an invisible 1. And then you go to the denominator and you say the cube root of y to the 12. The only thing you do is you take the exponent 12, you divide it by 3, and you end with y to the 4. Finding the roots of a sum. Now, there's a big misconception here. And the problem is that you cannot take the square root of each term individually. So in other words, you cannot take the square root over a plus and a minus. What you have to do is you have to simplify whatever you find under the square root. And in this case, you will see that there's like terms. So therefore, you can add 16a squared plus 9a squared, and it becomes 25a squared. And now you can deal with it. So now you can say the square root of 25 is 5. And in terms of the a, there's this invisible 2. You can divide the exponent by 2. On the next one, again, now there's 2 terms. They are separated by that minus. You cannot take the square root individually. What you have to do is you have to combine those two. If they are like terms, so you add them. Well, in this case, you subtract them. So it will be 25x squared minus 9x squared is 16x squared. And now that it's one unit, you can take the square root. So you say the square root of 16 is 4, and on x squared you divide with this little invisible 2 there, and the answer 4x. In terms of the cube roots, it works exactly the same. Again, you cannot take the cube root if there's terms there, if they are separated by a plus or a minus. First, you have to combine them and write them as one unit. Now you can say 8b to the 6 plus 19b to the 6. They are like terms, therefore it's 27b to the 6. And now you can take the cube root of the 27 is 3, and then in terms of b to the 6, when you take the cube root there, you will divide the exponent by 3. So the answer there, 3b squared. And then on this one, the cube root of 150k to the 3 minus 25k to the 3. Again, you cannot take the cube root over a plus and a minus. So you write them as a unit because they are like terms. You can say they simplify to 125k to the 3. And now you can say this cube root of 125 is 5, and the cube root of k to the 3, you will take this invisible, well, it's not invisible, it's there. You take that little 3 and you divide the exponent by 3. So the answer, 5k. In the next video, I will explain multiplication and substitution with algebraic expressions. Click on the video in the left-hand corner to take you straight to the next video.